we've nearly made it. We're at the end of all the A-level maths topic videos. We're on normal distribution and hypothesis testing. It is super easy. Unlike the binomial distribution, which can be a little bit more tricky, let's take a look. It says a gym manager claims his client base has a mean age of 45. A sample of 50 customers is taken and produces a mean age of 48.7 years and standard deviation 10 years. Stating your hypothesis clearly and using a 1% significance level, test whether or not the manager's claim is justified. Okay, so the first thing we have to do is define our distribution. So let's let x equal ages of clients at gym. Now, what are we claiming? Well, the manager is claiming, so the assumed hypothesis, what we're assuming to be true, is that the mean is 45. But what's the alternative hypothesis? Well, the alternative is we're just testing to see if the manager's claim is justified. We're not saying it's anything more, we're not saying it's anything less. We're testing if it's anything different from 45. And for that, we're going to look at the sample means. So the sample distribution. X bar is normally distributed. So we assume the mean of the sample is the same as the mean of the population. And then we have that here, standard deviation of 10. And this is going to tie into part B. We're going to assume that the standard deviation with the population is fixed. Okay, so it doesn't matter whether we're dealing with the population or the sample. We're going to keep at 10, but squared. But you have to divide by the sample size. Okay. Right. So the mean we've assumed is equivalent in the sample and the population. That could be an assumption. The standard deviation, actually, sorry, we need to kind of explain a little bit more that it's reducing depending on the sample size. But yeah, we're keeping it the same regardless. So yeah, what are we saying? What was I doing again? Oh, so yeah, now we need to do the hypothesis test. What I always recommend, guys, is to do a critical region test. Always find the critical region. So don't be finding probabilities here. Here's your normal distribution. Here's 45. My standard deviation is going to be the root of this, 10 over root 50. Find what the boundaries are, in which here you would reject H0 and here you would reject H0. We're literally saying what values or what ages would be sufficient in us saying that this is probably not correct. Do I have to get 50 years old to say that this is not correct? Do I need it to be just 46 years old? Do they need to be like, I don't know, 43 years old? We don't know. But what we do know is the areas. We do know these regions. If I call this X1 and X2, I know this region and this region need to be the 1% split. 0.5%, which is 0.005. 0.005. So we're saying the probability that X bar is less than X1 is 0.005. Now remember, guys, we need a cumulative distribution. So we can do 1 minus this, 0.995. And then we just do inverse normal in our calculator. Okay, so we're just going to go very simple. Menu A, oops, not that, menu 7, number 3, inverse normal, 0.005. And then I have 45, sorry, sigma is 10 over root 50. You have to always remember that they always ask for sigma first. I don't know why they do this, but mu is 45. So on one side I have 41.35. I'm not rounding it. It does become 7 after that, but it's not a big deal. Then I have 1 minus 0.005. 005. 48.64. So this value here is 48.64, and this value here is 41.35. So if we get any ages in these extremes, we would reject H0. So my critical region is any X value in the sample being less than 41.35, or any X value being greater than 48.64. Now, what do we get? 48.7. 48.7 is in that critical region. So you're going to say 48.7 is greater than 48.64. So we would reject H0. Now, when you reject, you're going to say there's sufficient evidence. So there's sufficient evidence to suggest manager's claim is not justified. Do not say it should be higher or lower. We've just said that the claim of it being 45 does not seem accurate given the evidence of what we found. Okay? And that's how we answer that one. Pretty simple. Say two assumptions you've used. Okay, so one really simple one is we've assumed that the, We've assumed the sample's random. Okay. We've also assumed that we can use the same standard deviation of the population in the sample. Okay. Yes, it reduces the variance, but we still use the standard deviation. Okay. So we've assumed we can use the same standard deviation from the population in the sample. And I guess you can say the same thing about the mean. We've assumed that we can use the same mean in the calculation as well. But in a nutshell, guys, this is the main part of the question. I just want to make sure you can answer something like this. It's very simple. With all hypothesis testing, just work out the critical region and you're all good. Okay? So guys, if you learned something today, I really appreciate it if you hit the like button, subscribe for more maths content. I'm still going to be making maths content, obviously. It's just this is the final topic of all the A-level videos. And if you're interested in my A-level maths courses, more details in the description. And feel free to join the Learn Gang Reddit page if you want to submit your own questions and get feedback from the community. I'll see you in the next one. Nice.